On to yet another question involving a solid. Donna has the solid shown below. Each edge measures 9 centimeters. So on my solid, they're saying that this edge is 9 centimeters. This one should also be 9 centimeters. This should be 9 centimeters. Basically every edge, right? All of the edges are 9 centimeters long. And they want to know what is the name of the solid. So we can tell it's a solid. These dashed in lines at the back here just mean that we can't see it from the view that we're looking at, but those are to the back, right? And it's just to help us, visualize our solid shape. So what solid do we know that consists of, what do we call this shape again? What do we call a shape? A four-sided flat shape that consists of 4 equal sides, because they said that each edge measures 9 centimeters. So this means that this shape here is a square, right? So if that's a square and all the other faces on this solid have the same measurement, so they are all squares as well, what solid do I know consists of square faces? And immediately, if I think about a solid with square faces, I will think about a die. And a die is what we call the cube shape, right? If we're familiar with playing with things like playing Monopoly and playing Ludo and Snakes and Ladders, we would know that the die, right, dice plural, those are usually cubes, right? They have 6 square faces that usually have numbers on them, so we're dealing with a cube. So we're going to write that in on our line. We're going to say that the solid, name of the solid is cube. Next, we have part B, which says, what is the total length of all the edges? Interesting. The total length of all the edges. So I want you to kind of think for a little bit. Pretend that you could dismantle this cube, right? Pretend the cube was made out of straws or something, or pallet sticks. If this cube was made out of something like that, we could dismantle it, and you could take every single edge and line it up. So let's just say, for example, the edges from the front square face. We took the edges of the front square face, dismantle it, and line it all up. We would have 4 straight edges connecting one to the other like that. And then if we took the edges from the top face, notice that the front square also contributes an edge to the top. So we'd have, again, we'll take, in this case, 3 edges from the top face alone, because we already have this edge here. And then the edges from the face to the side, right, on this side, because 2 of the edges of this face come from the top and the front face, we're just taking 2 edges from the side. So again, we're going to add that on, right? We're going to have an edge for the front, well, from the base and then the side, right? So the color coding is just for you to be able to kind of visualize, right? These edges are coming from different faces, and we still have the faces to the back and the base and the side there as well. Now the thing is, if we take the edge from here, right, that back edge, and then the other edge that completes that back face, you would have 2 edges, one of which would belong to the base. So we would add that in as well. So that's one, that's the next one there, alright? And then finally, we have the last 2 faces remaining, right? And this one edge, this last one edge here, is the only edge that we need, right? And we'd have all the edges for this one cube. Now, right? Now, that's just in case you're trying to reason it out just by looking at the solid and if you're breaking it up. Remember something as well. We already know properties of a cube, don't we? We've learned about the properties of a cube. We know that a cube is a solid shape consisting of only square faces. It has a total of 6 faces, right? So 6 square faces. We also know that it has how many vertices? We know that we have a total of 8 vertices, right? We could count them from just watching the solid. We could see the corners, right? 1, 2, 3, 4, 5, 6, 7, 8. And then the edges. How many edges do we have in total, right? And this is why, like I was doing the illustration here, to illustrate where each edge comes from. So in case you could not remember the properties again, you'd be able to kind of think about it, right? Visualize what you're doing. So in total, let's see how many edges we have. 1, 2, 3. We had 4 red edges, right? Because the first face was the one that we did, and we would have gotten all 4 sides there. So 7 so far, and then 3 from the top 7 and 3 is 10, and then these other 2 which total to 12. So we have a total of 12 edges, right? And we counted them. We just, broke down our cube like if we had made the cube out of palette sticks. So 12 edges, right? And if we could figure out that, if we could figure out the number of edges, we'll be able to figure out the total length of all the edges by simply doing a little bit of multiplying. So if I have in total 12 edges, right? So number of edges is 12, right? Number of edges is 12. Length of one edge is 9 centimeters. So each of these edges is 9 centimeters. So basically what they're saying is, if we break up the palette stick cube and put all the edges together like this, we're supposed to have 12 9-centimeter lengths. So this is 9 plus 9 plus 9 plus 9 plus 9 plus... You get the idea, right? And easily, if we remember that adding 9 to itself so many times is just basically multiplication, we just multiply the number of edges by the length of one edge. So if we remember our 12 times tables or even our 9 times tables, we'll be able to do this with ease. So what is 9 multiplied by 12? 9 multiplied by 12 should give me 108 centimeters. So that's my answer there, right? The number of edges times the length of one edge. Multiply those two numbers and you will get 108, right? So that's how we get the total length of all the edges. Now, the last thing that we need to do, right? They are saying that Donna stuck 7 stars on each face. Again, this is really and truly asking us about the properties of the cube. So once you recognize the shape is a cube, immediately recollect all the properties that we just discussed. We discussed vertices. We said we have 8 vertices. We discussed that the cube consists of only square faces, and how many of those faces do we see in a cube? If you remember correctly, you would know that we said that there are 6 square faces. So if she's sticking 7 stars on each face, right? 7 stars on each face. How many faces do we have in the cube? 6. How many stars on each face? They said 7. So total number of stars, because they're asking how many did she use. So the total number of stars, what do you think we should do? What do you think we should do to get the total number of stars used? thought cross your mind that you have to do, you could say you're going to add however many times 7, right? So you're going to put 7 stars, and I'm just going to illustrate on the front face just for illustrative purposes, right? Just bear with me. Okay, so basically this is what she did, right? She make a star, right? So anyway, she have stickers or something to make her life easier, right? She's sticking star stickers on each of the faces, and she said that on each face she's putting 7 stars. So on the face, you should see 7 stars, and when she's done on each face, we should see a total of 7 stars per face. So we're going to be adding 7 to itself a total of 6 times because we have 6 faces. So 7 plus 7 plus 7 6 times could easily be written as 7 multiplied by 6. So we'll get our answer for the total number of stars, right? So 7 multiplied by 6 is 42. So in total, she would have used 42 stars.